Now calculate, boys. Root 2, the value of root 2 is 1.414. Yeah. 10. So the value of root 2 is 1.414.
Ma'am, you're
What
not
will be your
sharing
final
screen,
answer?
Ma'am,
screen,
I
screen, screen, screen,
think
screen.
Everything looks.
ma'am, you're not sharing the screen.
Minus g m squared by L, 4 plus root, the value of root 2 is 1.414. So it will be minus gm squared by L into 5.14.
Oh, ma'am, we can't see your screen, ma'am.
Which one I'm subtracting? No, that's the, because potential energy is negative, U is equal to minus the the negative sign shows that the force between both the bodies are attractive. Fine, boys.
Ma'am, you aren't sharing.
So we'll go back to your the
Ma'am, can
other
you hear
chapter.
us?
I think ma'am can't hear us.
Ma'am,
Yeah.
can you hear us? Yeah. Shall we message Steve?
Ma'am. Yeah, she can't hear us.
Just type in
Ma'am, ma'am,
the
ma'am, ma'am.
chats.
Ma'am, can you hear us? Ma'am, can you hear? Ma'am, can you hear us?
Shall I close this PowerPoint? I'll go for the next one.
Yes,
Shall I
ma'am, you can do it.
close this one? How
Ma'am,
you people are sitting without AC?
Yes, ma'am. Ma'am, close the PowerPoint, ma'am.
ma'am, you have to share the
Oh,
PowerPoint.
sorry.
Share it, close it.
Sorry.
Ma'am, can you
Ma'am,
hear
can you hear
us?
us?
No, yeah, yes, boys, yes, I can, because it was, there was a
Oh,
problem
Ma'am, can you
in
hear us?
the. No, I can hear, I can hear.
Ma'am,
So
you're
I'll
not
go
Can
for
sharing
you
the
it.
switch the
screen.
PPT?
Ma'am, you're not sharing the screen, ma'am.
No, no, I'm switching over. Yes, boys. I'm
Ma'am, we
switching
didn't
over to
see the
Elastic.
sum.
Ma'am, we didn't see what you wrote because it was not sharing.
Ma'am, we didn't write the answer.
Okay, fine. I'll just go. Sorry.
Hakuna Matata.
All code words. Who is that? Once again. Can you see the PPT now,
yes,
boys?
ma'am. Yes, ma'am.
Complete your work.
Ma'am,
Yes,
should we substitute the value of √2?
yes, root 2 1.414. So that
Okay,
becomes
ma'am.
5.414. That's it. It becomes 5.414. So your final answer is minus 5.414 gm squared by L. Shall I go for the next one, boys?
Ma'am, so it'll be 5.41, yeah?
Yes. It's 5.414.
All right, ma'am. Thank you, ma'am.
So let me switch over for the next. So I'll go for the other one.
Ma'am, we have to find the potential at the center of the square also, right?
How will you find the potential?
Is it 0, ma'am?
It will be 0.
Okay, ma'am.
Is it 0? Will it be 0?
Ma'am, because it's equal masses and equal distances. I'm not sure,
Will
ma'am.
it be 0? Then just do this as a homework. Let us see. Boys, do this as a homework. The potential at the center. Just check. What will be the potential at the center? Okay. So next I'll go for can you see this elasticity PowerPoint presentation? Elasticity, can you see, boys? Yes, sir?
Yes, ma'am.
What was the previous one? We completed Young's modulus. Steel and brass, did we complete this? You completed this, that's it. Next we'll go for, there are 3 kinds of elastic moduli. One, what we have learned is your Young's modulus. Now comes your bulk modulus. Now, what is the difference is that Young's modulus, you're going to, this is applicable in case of all your metallic wires. Generally, it is longitudinal strain. The strain undergone by any metallic wire or a metallic rod. There you use your Young's modulus to what extent the material can withstand the stress. If you have a metallic wire, you apply a load at its lower end. To what extent it can withstand this load before breaking. That is what is your Young's modulus. Now we go for what we call it as bulk modulus. Bulk modulus is nothing but if you have your material in the form of a sphere or in the form of a cube or a cuboid, then the change in the shape, but sorry, size, but not the shape. See that? Now, bulk modulus tells us the compressibility of a fluid or a solid. Now, what does it mean? You know that gaseous material are highly compressible compared to your liquid. Your gases are highly compressible compared to your liquid. Liquids are highly compressible compared to your solid. So your bulk modulus, the value of your bulk modulus gives you an idea whether a fluid is compressible or not. If the fluid is highly compressible, then it has low bulk modulus. If the fluid is having low compressibility, in that case, if you cannot compress your liquid to a greater extent, then it has a higher bulk modulus. This bulk modulus, we'll define it later. Bulk modulus tells us the compressibility of a fluid or a solid. You can see in this experiment, right, boys? For example, any gases as well as your air. Now, which is more compressible? Air is more compressible compared to the other gases. So bulk modulus tells us the compressibility of a fluid or a solid. Something is highly compressible it has a low value of your bulk modulus. So if you know the value of the bulk modulus of different materials, you can check whether they are compressible or not. So high compressibility, low bulk modulus, low compressibility, high bulk modulus.
Ma'am, should we
A
write this?
diamond, just write boys, just
Okay.
these 2 points, because you should know why are you studying about bulk modulus. Why do you want to know about an idea for your bulk modulus? Bulk modulus gives you an idea of compressibility. This is very important in case of automobiles, where you have these engines are filled with liquids, brake liquids, even your brakes. What we use when you use your brakes, if you see, it is a cylinder piston arrangement. Have you seen the engines? Have
Yes,
you
ma'am.
seen the engines?
Yes, ma'am.
Yeah, it's a cylinder piston arrangement where the piston will move inside a cylinder, where the cylinder is filled with liquids, in some cases gaseous materials also, liquids in case of your brake fluids. So in all your brake system, you have brake fluids. Now these brake fluids are these brake fluids compressible? They're viscous. Are they compressible? Should you use a high compressible? You should not. No, when you apply brakes, right? Yeah, correct. So in that case, the liquid should be compressible or not? Yeah. So that's the reason, boys. It has a wide application. Bulk modulus has a wide applications. It wants to check. See, if the brake fluid is not compressible, can you apply a brake? The next chapter you will be studying about hydraulics, how your brake systems are going to work. In Pascal law, you will be studying about. Have you seen car washing? Seen the car washing? You have car washing. They use hydraulic system. Yeah, to lift the car. Actually, they don't apply so much of force. Actually, the car is say the mass of the car is massive, compared to the force applied. The force you apply to move the car up for car washing, it's not a larger force. They apply a smaller force, but that force which multiplies and lifts the car up. Next chapter you will be studying about how pressure can be transmitted through liquids. So this and the next chapter are finds important application, especially in your automobiles. You know your diamond has low compressibility, hence it has a high bulk modulus. Now, how will you define your bulk modulus? Suppose you have any material in the form of a cube, right? It has a volume V. Now you need to compress this. If you have to compress, you are going to apply force on all the edges, on all the surfaces, and this force is acting perpendicular to the surface. So what type of stress it will create? This force per unit area will be normal stress. So then in that case, you are compressing this cube or the cuboid by applying a force, and this force is a normal force, a force which is acting perpendicular to the surface. Now what is going to happen is that the volume now shrinks to V dash. There is a decrease in volume because this material is compressible. Only when the material is compressible, you can apply a force and compress it to a volume V dash. You are compressing it, right? Now, this material will show some amount of resistance. It's not easy to compress any object. In that case, you are applying a force. The resistance shown by this object on the application of the force, its shape is going to change, its size is going to change, and that measures your bulk modulus, right? Or else I can say to what extent this object is going to shrink. Sometimes what happens, the object crushes out. If you apply force on all sides, normal force, at one point the body might break. To what extent this body can withstand these, that measure is given by bulk modulus. To what extent some bodies will immediately, some bodies cannot withstand. They will immediately break up. Some bodies can withstand. So if the bodies can withstand these deforming forces, so that it's compressed, the forces are trying to deform it. So if it can withstand such large forces, then we say the bulk modulus of the object or the material is having a greater value. Because now how do you measure your bulk modulus? So keep this in mind. You have a body of volume V, right? You are applying a force so that you want to compress this object. Its volume is going to decrease, right, boys? Suppose when you apply a force and compress this body, some bodies will break, some bodies can withstand. To what extent the bodies can withstand these deforming forces is measured by what we call it as bulk modulus. The bulk modulus gives you to what extent the body can withstand such high pressure. Bulk modulus is the ratio of volume stress over volume strain.
Ma'am,
When you had, yes, boss?
even
Yes.
for Young's modulus, there's a change in volume, right? Because it gets
No, it's
stretched.
change in length. Change in length. It's a longitudinal one, boys, where the object is going to extend or compress along a straight line. It's a longitudinal strain. Here it is volume strain.
Okay, ma'am. Ma'am, and what does bulk modulus applies to uniform volume compression mean? Like, what is uniform volume
Bulk
compression?
modulus applies to uniform volume compression, which means the force which you are going to apply, the force which is acting per unit area on all the surfaces should be the same. That's what it is. Because force per unit area is nothing but the pressure. So what is volume stress? Force by area. What is volume strain? It is change in volume by original volume. I think it's just I don't know why your timetable is showing last 2 period physics, right? Yesterday it was physics, today also it's physics. Last, no. I don't know why they are keeping physics at the last period. Anyway, right, boys. Volume strain. Physics should be before the break. You have English before English in the first half. 6 p.m. No, lighter subject, if it is at the fag end, it's better to understand. And now I'll just finish. I'll go for the numerical. It's better.
But
It's better to solve numericals. Yes, boys.
like
Yes.
physics has 7 periods in a week.
Yeah, correct. I understand.
Yeah, but
what
chemistry has only 6. So like
yeah,
chemistry is missing out.
the timetable has been adjusted because we modified for practicals for grade 12. We need to adjust for the practicals for grade 12 because that was more important.
Ma'am, in the formula, why is it negative?
You tell me, why is it negative? Why is
Uh,
that negative?
I don't know, ma'am. I'm not sure.
Can someone tell me why the bulk modulus is negative? Is your change in volume, right? Is a change in volume a positive quantity or a negative quantity? What is a change in volume? Final volume minus initial volume. Okay, just tell me. Yeah, so in that case, final volume is lesser than the initial volume. That's the reason the change in volume is negative. Sorry, they should have put here a negative value. That's what I'll just copy down this. We'll do numerical based on this so that it will be easier for you. So the negative sign indicates there is a decrease in volume. A change in volume means the volume has been decreased on compression.
Ma'am, so when we substitute values, will that negative sign go away? Or we're
So when
supposed
you
to
substitute,
substitute the magnitude?
it will be there, boys, because the volume would have decreased. Yes.
Okay.
I'll go for the next one. What will be the SI unit? What will be the SI unit, boys? See, the lower one, this will not have any dimensions, a ratio. So only the dimension is newtons per meter square. So all your modulus of elasticity, Newton per meter square. Right, boys. The reciprocal of the bulk modulus is called compressibility, and it is denoted by the letter K. No need for the other statement, only till this you can write. The reciprocal of the bulk modulus is called compressibility. It is denoted by K. Whether it is first period or last period, somehow you have to manage to learn, boys. Because you cannot give a particular subject before break. Every time you can't give a particular subject before break. Sometimes it happens that you will get your period in the second half, but you need to balance it. Even in grade 12, if at all you get your physics the second half, somehow you have to manage. The reciprocal of the bulk modulus is called compressibility. It is denoted by K. No need for the definition. You should know what is. Now look at the compressibility of various materials given. Can you see which one has a greater value of compressibility? All these are 10 to the power of 9. This is the bulk modulus. The value of bulk modulus of solids and liquids, all these are 10 into 10 to the power of 9. Look at air. It's 10 to the power of minus 4. So the bulk modulus is less. Then what happens to the compressibility? Increases. Bulk modulus is that the material will not allow, right, or it can withstand the pressure. It will not immediately deform. Bulk modulus gives you an idea when a deforming force acts on a substance, sorry, or a material, the material will not immediately change its dimension. It will resist to deforming forces. So if it resists to the deforming forces, you cannot compress it. So that is why bulk modulus is if the value of bulk modulus is less, the
Ma'am,
compressibility is.
ma'am, is this table in the textbook?
This is the, I think so the values are being given, but might be the order might be different materials. I'm not very sure about it. Was you need not by heart. You need not by heart. You should know the bulk modulus of gases are very low compared to solids and liquids, which means your compressibility, gases are easily compressible compared to your liquids and gases. Now you know the value, formula for your bulk modulus. What is that? What is that? Force upon area divided by delta V by V. What is force by area? What do you term force upon area? What is force upon area? Pressure. Pressure divided by delta V by V. So this is your bulk modulus. Now look at the question and start doing this, boys. Compute the bulk modulus of water from the following. What happened? It's time up. Fine. Boys, keep practicing, keep learning